Hi everybody, my name is Mike. This channel is going to be about print graphics and color management, both for production print professionals and at-home printers, graphic artists, in an attempt to demystify certain areas of print and graphics. This first video is going to be about rendering intent, which is something a lot of people have seen but don't fully understand or even know what it is. In fact, when you've gone to print a document at home, or if you're a production print individual sending something to the RIP or press, you may have seen options that look like these. So what is rendering intent and when do you use it? Well, rendering intent comes into play when your file presents with a larger or smaller gamut than what the output profile of your print device is. So in order to understand what rendering intent does, you first need a brief look at what a color gamut or profile is and how it functions. If we take a look at a 3D model here of a CMYK color space, a common print profile, whether it be a swap profile, which Adobe likes to default to, or a Grackle CMYK color space, it'll look roughly like this. This is it from the top, this is it from the side, and in each area of the gamut you have a little parking spot where a particular color lives, and an output profile is going to have a full lot of colors that the press can render. So we see here, if we were printing, this is the CMYK here in the center. This is probably some type of RGB color profile on the outside. If you were sending a photo that was saved in RGB to a printer, it would have to take all these colors that live in the RGB color space and bring them into the CMYK space. And rendering intent is going to tell the printer how to render those colors, particularly the ones that are outside the color space. So what are the two most common types of rendering intent? Would be a photographic, or nowadays they're using the term perceptual. Same thing. It's whether it says photographic intent or perceptual intent, it's the same type of rendering intent. And our other most common one is a colorimetric rendering intent, and usually says either absolute colorimetric or relative colorimetric. It usually defaults to relative. We can maybe get into what the difference between absolute and relative are maybe in another video. Not much to it. It's just a matter of white point. That white point being your paper or substrate, whatever you're printing on. Absolute will actually shift your entire color space over to compensate for white point. But generally speaking, relative colorimetric is what most people are going to print with. Unless you have a production press that's been profiled and the white point of the substrate is entered into that color data. But that's for another video. So what happens with that photo, that RGB photo that you're printing, and you're printing it to a CMYK printer? Generally speaking, you're going to want to use a photographic rendering intent, which some people may know well enough to select and use it. Others may not even dive into that menu, and whatever the defaults are, they are. It could even be a colorimetric rendering intent, which could be disastrous for your photos, and we'll see why. So let's say you're printing from one larger CMYK color space to a smaller one. This circle represents what would be everything that the printer can print in the profile that you selected as an output profile. These colors outside the circle, let's say they're a couple colors that exist in the file but don't fit into what the printer can render. So back in the day, these colors would just be simply omitted, and you would get nothing. It would simply wouldn't print anything at all. In fact, if you sent an RGB file to a CMYK printer, you might just get a white box, a little halo with nothing in it. That was before at-home printers and even certain presses and RIPs started using rendering intent as part of a standard RIP process. So we have several colors not within range of the press or printer. And so what happens? You select colorimetric rendering intent, and it has to bring these colors in somehow. And first and foremost, everything that's in the file that is also in the press profile remains locked. Does not move any color that it can already render, not at the expense of the colors that it's trying to bring in. And all it's going to do is take these colors and simply bring them to the edge of the gamut. Anything that already lives in here has a match, a lab value that can be reproduced, remains untouched. So in the event you're going from a larger CMYK profile to a smaller one, or perhaps you have a spot color PMS Pantone color that's in the file, that'll be brought to the edge of the gamut here. It's not going to match your Pantone. In fact, it's not going to match any of the colors outside of the gamut. It's just simply going to bring them in so they can print. And likely it's going to be overlapping another color that already lives at the edge of the gamut here. So your really dark blues might come out a little bit purple is a common thing that happens. Oranges often print a little brown, and generally because they live way out here. So it does the best that it can do, which is a debatable statement. Having your dark blue render as a purple, generally as a pre-press professional or a technician, you would create a new color so that it at least represents as blue, rather than the default edge of the gamut purple color. So that's how that works, really. And generally speaking, you're not going to have too many colors that are way out. If it's one CMYK profile to another, you're not going to have an oddball color that's profoundly out of the gamut. It's probably going to be somewhere over here. It's just a blue or an orange that's slightly out of range that it's just going to bring in so it can print. And that's basically colorimetric rendering intent in a nutshell. So what's different about photographic? Now photographic, if we take a look at that comparison here, is going to have a significant amount of colors outside of the CMYK color space. A lot. So how are you going to handle all those colors? You can't bring them all to the edge of the gamut, which is exactly what would happen if you selected this rendering intent. You'd have tons of colors piled on top of each other, which creates a drab image, especially for a photo that should have smooth transitions. So how does this function differently than this? Well, what this is going to do is it's going to bring your colors into the color space, obviously, because it has to print them. But it's going to allocate them a bit smarter than colorimetric. So if you had a color that was going to be brought in on top of this existing color, it'll bring this color in and it'll actually move all your existing colors to compensate for the color you're bringing in. This allows all the colors to live in the color space while avoiding overlaps in gradient transitions. You're still not going to get all of your colors because you're going to have multiple colors from outside the gamut that may stack, but the color that already existed here may move over a little bit, and it'll push everything around so that nothing is going to be either dropped down of the profile or have so many overlapping colors that your photo is going to look washed out. You're not going to have vibrancy. A lot of things are going to happen. Skies or your highlight tones may appear choppy or banded, and then that happens because you've had 3 or 4 colors that have that light blue in the sky have piled up on top of each other. So it's got a whole bunch of light blue in that one area, but the next transition of the sky doesn't have a color in that parking spot. It's gone. It's either going to be the same light blue, and then it's going to have a hard flux to whatever color comes next, or you'll have some dead area altogether. It'll look blown out. So that's the difference between photographic and colorimetric. Generally, production printers are going to be using these. You're going to have a pre-press technician that's going to be working on the files, and we can go over some of these pre-press techniques in another video. How to pre-flight files, how to prevent potential photos from coming through in this manner, how to apply 2 rendering intents. So say you have a mixed file that's CMYK and RGB. It can say, route all RGB elements to this rendering intent and all CMYK elements to this rendering intent. And with that, you can actually achieve quite nice photos of, rather than the old way of converting them in the file, which is something we used to do back in the day. Anything that came over RGB had to be converted in your design software to CMYK, and then you kind of just took a guess at color correcting how it's going to look once it's printed. Whereas these rendering intents have gotten better and better over the years and actually produce pretty good results without having to manually convert the file, and in which cases a lot of color data is permanently lost. Next time you go back into that file, you're not going to have your RGB photo anymore. If you're a smart graphics guy or girl, you'd probably have a file saved with all the originals in it. But it's nice to have this to kind of calculate the thousands, if not millions, of conversions and placement of colors individually, rather than a blind curve adjustment in Photoshop or something like that, in an attempt to kind of predict where the press is going to be at that time and how it's going to print that photo. So I think that's it for right now. I'm going to wrap this up. This is my first recording, so bear with me. I'm a bit camera shy, so hopefully the first video I post, or maybe this one, I'll record a face-to-face beforehand, and so you guys get to know me a little bit, and a little bit about my background, and we'll go from there. So, all right, thanks everybody. Have a great day.